Lesson 3.6, looking at quadratic inequalities. Quadratic inequalities can be graphed using same techniques as linear inequalities. We're going to solve them the same way we would solve quadratic equalities or quadratic equations. So we're kind of merging that concept of quadratics and inequalities. So here in example 1, we have this inequality. Y is greater than x squared minus 3x plus 2. If you are asked to make a graph, easiest thing to do is to use a graphing calculator to get a table of values. Right? So I am going to go in and I'm going to go into y equals, and the TI-83 cannot graph inequalities. I believe Desmos can, but I can use my TI to get my table of values. Right? So x squared minus 3x plus 2. I can get a quick look at the graph, and then I'm going to go to table. Right? So I am going to look for symmetry in the data. Right, and it's actually right here, but notice there is no point listed that does not have a match. So that means my vertex is going to be a decimal. It's going to be right between 1 and 2. So my vertex is going to be at 1.5. Okay, so some data that I'm going to use then would be 1, 0, 2, 0, 0, 2, 3, 2, right? And that's really all that's going to fit on my graph. If I really wanted to get that vertex point, knowing that it's going to be at 1.5, I could say, oh, that's at negative 0.25. Right, so then I'm going to go through, I'm going to plot my points like I would for a normal equation. Okay, and I'm going to graph it. Now, when I draw my line for my graph, if this was a linear inequality, right? We have that concept of either a dashed line or a solid line, right? Dashed line is for less than, greater than, and solid line is for the or equal to's. Because this is a y greater than, I am going to connect these with a dashed line. And then I have to decide, since it's an inequality, where do I shade, right? Y is greater than this quadratic. I've graphed that quadratic, so greater than is going to be above my dashed line. Same thing for example 2. I'm going to use my graphing calculator. Y is less than or equal to. So as I'm reading this off, I'm thinking, oh, it's an or equal to, so I'm going to be using a solid line, right? X squared plus 2x plus 1, and my table of values. Right, I'm looking for symmetry in the data. So right here, I can graph these points. I have negative 3, 4, negative 2, 1, negative 1, 0, 0, 1, 1, 4. It was a or equal to, right? So it's going to be a solid line. Y is less than the line, right? So I'm going to color below that line. Now, solving these algebraically, we're going to solve them like we would a quadratic equation, and then at the end, we have to do one extra step, right? So I am looking at this like it is an equation, x squared minus 4x plus 3, right? I'm trying to figure out what multiplies to 3 but adds to negative 4, right? So that would be negative 3 times negative 1 gives me that positive 3. And adds to negative 4. Okay, I'm going to split this. I'm going to have x minus 3 is greater than 0, x minus 1 is greater than 0, and then I'm going to solve these up, right? I have x in 3 and x less than 1. Okay, when we go to write our finished inequality, it is important that we look at we need to determine how to write our final inequality. Right? So I know that the values of 1 and 3 are an important part of this inequality. I get that from this part right here. Right? So I am trying to decide then, is my valid answer going to be between the 1 and 3, or is it going to be over here, less than 1 and greater than 3? And you typically are going to have those two options, right? You're going to have where it's between the two values, or it is less than 1 or greater than 3. So what I'm going to do is I am going to test some values. In reality, you could get away with just checking one value, because you know it's either going to be these two values, right? You're going to check values for here, here, and here, right? So you could check a 2, you could check a 0, and you could check 5 if you wanted to. And you're trying to determine if these two values are true and this value is false, or if these two values are false and this value in the middle is true. We can shortcut that because it's got to be one of those two possibilities. So what I am going to do is I am going to check 0, because 0 makes things a very simple check. So I am going to check a 0, and I am going to plug it in. X in, 0 in for x, right? So 0 squared minus 4 times 0 plus 3 is less than 0. So this is 0 minus 0 plus 3 is less than 0. That is not a true statement. So I know that this is not true. So I know that this middle part has to be what I'm looking for. So I know that x is going to be between the 1 and the 3. Looking at example 4, again, I am going to solve this like I would an equation. Right? What multiplies to 5, negative 5, and adds to positive 4. Right? So this would be negative 1 and 5. Right? Negative 1 times 5 is negative 5. Negative 1 plus 5 is positive 4. So I'm going to have x minus 1, x plus 5. Right? I'm going to split these. So I am going to have now, I'm going to have x equals 1, x equals negative 5. So building that little number line, I know that the numbers -5 and +1 are important. I'm going to check 0 again, right? So I'm going to check if this is the valid part of the answer. So 0 squared plus 4 times 0 minus 5 greater than or equal to 0. Okay, that is not a true statement, right? -5 is not greater than 0. So this is not where the valid answer is. So I know that these two outer parts are. So I know that x is going to be less than or equal to -5, right? It had that or equal to in the original, or x is greater than or equal to 1. So solve these like you would equations, linear inequalities and quadratic equations kind of merge together with that extra step in at the end with that little number line check. That brings us to the end of lesson 3.6.